Hello everyone, and welcome to today's webinar in the SERDP and ESTCP webinar series. My name is Rula Adib. I'm a senior principal at Geosyntec Consultants in Oakland, California, and the coordinator of the webinar series on behalf of SERDP and ESTCP. I will be facilitating today's webinar. The webinar will consist of a brief overview of SERDP and ESTCP by Mr. Timothy Tétrault, followed by a list of upcoming webinars in the series. After Tim's opening remarks, we will transition to the technical portion of the webinar. Today's event features 3 presentations on cybersecurity and its impact on installation energy management. First, Dr. Michael Chipley from the PMC Group will provide a Department of Defense perspective on the issue, followed by a short Q&A session. Dr. Chipley will be followed by 2 technical presentations featuring newly funded ESTCP projects, each of which will be followed by a short Q&A session. First, Mr. Kevin Jordan from Resurgo will discuss a new capability to mitigate and recover quickly from online and insider cyber activities directed against SCADA infrastructure. Then, Dr. Daniel Quinlan from Lawrence Livermore National Laboratory will talk about mitigating the risk of a cyber attack from software upgrades to both critical electric grid infrastructure and building automation systems. We will conclude the webinar with a longer Q&A session involving both Dr. Jordan and Dr. Quinlan. Today's broadcast will be listen only. You may submit your questions by using the chat box on the left-hand portion of your screen. You do not need to wait until the Q&A period to submit your questions. In fact, we do encourage you to submit questions well in advance of the Q&A session. On this slide, we have provided a few suggestions in the event that you experience difficulties with the broadcast audio. Typically, any delay will be fixed if you refresh your screen or call into the conference line. However, if you continue to have problems, please submit a comment using the chat box in the lower left corner of your screen. With that, I would like to introduce Mr. Timothy Tétrault, who is the SERDP Program Manager for the Energy and Water Program Area. Before joining SERDP and ESTCP, Tim worked at the National Renewable Energy Lab, where he focused on energy efficiency and renewable energy project development for the federal sector. Tim?
Thank you, Rula, and welcome everybody to today's SERDP and ESTCP webinar. I think we have an exciting presentation for you today on a topic that's been in the headlines pretty regularly. To start, I'll go over some background on our program. SERDP is the Strategic Environmental Research and Development Program that was established in 1991 by Congress as a partnership between DOD, the Department of Energy, and EPA. SERDP's mission is to identify and address high-priority environmental science and technology opportunities that focus on DOD requirements. SERDP funds both fundamental research as well as advanced technology development that ultimately impact real-world environmental management. Next slide. ESTCP is the Environmental Security Technology Certification Program in which we demonstrate innovative environmental, energy, and water technologies. These investments capitalize on past investments under SERDP or other research programs and are designed to transition technologies out of the lab and into the field. Especially important in all ESTCP demonstrations is the ultimate transition to implementation and regulatory acceptance. SERDP and ESTCP are complementary programs with much of SERDP research occurring in the lab and pilot scale with occasional field efforts, while ESTCP demonstrations are primarily at the pilot and field scale with occasional supporting lab efforts as well. There are 4 program areas in SERDP and 5 in ESTCP. The Energy and Water program area is only in ESTCP, while the other 4, environmental restoration, munitions response, resource conservation and climate change, and weapons systems and platforms, are SERDP and ESTCP programs managed jointly by designated program managers. Our webinar today is focused on research and demonstrations that are conducted under the Energy and Water Program area. Energy and Water Program supports a variety of demonstrations of innovative technologies, primarily in 3 areas of research: smart and secure installation energy management, which would include microgrids, energy storage, and methods for participating in ancillary service markets; efficient integrated buildings and components, which includes a broad array of energy and water technologies; and distributed generation, which covers technologies that provide power to buildings, support microgrids, or help DoD achieve its energy goals. Today's webinar will provide an overview of DoD's recent work to address cybersecurity risks to IT and industrial control systems, along with presentations from 2 demonstration projects that are just getting underway of technologies that address different aspects of cybersecurity risk. Our webinar series will be highlighting research and demonstration efforts from each of the 5 program areas. The next webinar is scheduled for October 20 for the Resource Conservation and Climate Change Program area, covering DoD decision-making and climate change. Our next Energy and Water webinar will be held on January 12, 2017. You can find detailed information and register for upcoming webinars at this link. Thank you, and I hope you enjoy the webinar today. Back to you, Rula.
Thank you, Tim. And it is now my pleasure to introduce our first speaker, Dr. Michael Chipley. Dr. Chipley has over 33 years of consulting experience in program and project management in the areas of cybersecurity, energy, environmental and sustainable design, critical infrastructure protection and analyses, building information modeling technology, and emergency management disaster recovery. He is an active member in professional societies and also teaches seminars and courses on IT and OT, security, and building systems conversions. For the past 5 years, Dr. Chipley has been providing subject matter expert support to the Energy Installations and Environment Office, liaison to the Department of Homeland Security Cybersecurity Evaluation Tool, and the Department of Defense Electronic Mission Assurance Support System development teams to incorporate control systems into traditional IT processes. It's our pleasure to have you, Dr. Chipley. Please proceed.
Thank you, Rula. Timothy asked me to give everybody an overview of the DoD's adoption and implementation of the Risk Management Framework, a NIST standard. This actually started back, as Rula said, back around 2010 in my time when I first started supporting the Energy Installations and Environment Office at OSD. And at the time we had what we called smart installations. It was a great concept to dramatically improve our energy efficiency and manage our energy programs. And it was also kickstarted then with the adoption or the ARA legislation that provided additional funding to buy the smart meters or advanced meter infrastructure. The services, Air Force and Army particularly, installed thousands of these meters, and then it was rudely interrupted when we got a denial of authority to operate by the CIO. So that forced us then into the fact that we were going to have to partner with the CIO to go out and come up with cybersecurity processes and methodology to secure our what we call operational technologies, or in the terms of industrial control systems. About that same time, Shodan became a known entity, and very much like Google or Bing for web searches, Shodan goes out and finds connected IP devices. And around that 2010-2011 time frame, all of a sudden we started to find that we had literally hundreds of military installations and thousands of our facilities being exposed directly on Shodan with no login credentials, direct access to our HMI, human machine interface operators consoles. So again, this was now a wake-up call to the DoD that we now had to go out and put in place a policies and guidance and procedures now to cybersecure our industrial control systems, operational technologies, building control systems, energy systems, etc. Common to all of our control systems are what are called building controllers or field controllers. And as you can see, it's a very small unit, about the size of a phone typically. And on one side will be what looks like traditional Cat5 or RS-232 or 245 cables coming in. And on the back side are the copper wires that go out into the actuators, sensors, thermometer, temperature sensors, those types of things. And within the Department of Defense, those types of controllers are just about in everything that you can imagine. And so every one of these devices now, if they're misconfigured, can expose the entire DoD network to attack or exploit. So as you can see, back around 2012, Daryl Hagley came in as the government program manager, and we began a very concentrated effort now to develop policy and guidance and a number of resources to help the Department of Defense begin to address the facility-related cybersecurity issues. So we published a number of documents to get us started. We initiated several research programs such as SPIDERS and then the SERDP-ESTCP program. We worked with the CIO to then incorporate what is a DoD term called Platform Information Technology, which now incorporates, again, all of our facility control systems into the DoD instructions. So the 8500 and 8510 was the adoption of the risk management framework and cybersecurity of our PIT systems. We then incorporated these requirements into our workforce documents, and our newest one, the DoD 8530 network security, now requires all operational technology and control systems to be follow the RMF processes. We also work with CyberCom then to develop advanced tactics, techniques, procedures. That was published earlier this year. And then finally, we developed a cybersecurity and facility-related control systems, UFC, which was published last week. And I'll show some of these documents here in a bit. All of them are fundamentally tied to the NIST Special Pub 882 Industrial Control System Security Guide, which again was published in May of 2015. So all these documents were essential for us to be able to develop policy and guidance to move forward. We also achieved some high-level support when we had the 8-star memo that was sent by the NORTHCOM and PACOM commanders to the SecDef, asking that control systems now be incorporated into the CIO SecDef scorecard. So that is currently in process. Some pilot templates have been proposed, and we're testing those out now. But again, it's now risen to the level of the SecDef that the cybersecurity or control systems now has to be part of the overall DoD process. We also have Congress taking a very active interest in what DoD is doing. And as you can see here, SecDef is to deliver a report with 180 days of the NDAA being signed on these topics here. And as you saw in those previous slides of our efforts underway, we've actually made substantial progress in addressing and beginning the inventory of these systems, putting in place basic cybersecurity practices and hygiene. But again, we have a long, long way to go. We are in our infancy in this area. This is where our researchers and our principal investigators are going to be able to help us now develop the processes and procedures to cybersecure these systems. Here's an example of what platform information technology in the DoD instruction. As you can see, it includes basically all of our facility-related, to include our vehicle and tactical assets that are tied to our fixed military installation infrastructure. And so we've now got literally thousands of these systems to now go out, find, categorize, and then get them cyber secure. Here's the DoD network publication. This one came out earlier this year, late December 2015. And in this publication, as you can see, it now references directly to use NIST 882 for those that are both owned and operated on behalf of the DoD components. So this would include our privatized assets that are also supporting our military installations, in particular privatized utility systems. A key to this document is the term Joint Information Environment. The older term, the Global Information Grid, is being sunsetted. We're now going to move into the JIE, As you can see, the installation processing node now becomes the singular point of entry for all network traffic entering onto an installation. It distributes out to special purpose processing nodes, in our case, our building control system operations centers, and then our tactical processing nodes, which would be our field deployed assets. Here's what a conceptual diagram of a control systems environment in the JIE. As you can see, it comes into the Network Operations Security Center at the installation processing node, and then we transfer over to Control Systems Operations Centers in that special purpose processing node, and then we start to have all of our military installation control systems reporting into some sort of a centralized monitoring and reporting capability. The key to this is that we also want to have now a test and development environment where we can have a number of tools to support our continuous monitoring activities, as well as do patch management, software management, and then test these things before we put them out onto the control system. Within the UFC for cybersecurity and facility-related control systems, this is the reference architecture diagram. As you can see here, it's 5 levels, and level 4 is where we then basically have our control system and operator's console. And you can see an enclave boundary as defined by that red dashed line. We basically need to identify everything within that boundary and then put in place, again, basic cybersecurity protection processes. At level 4, where it's the traditional IT type of hardware, software, servers, workstations, most of which run Windows platforms, we can apply basic IT processes to it. And those are pretty well known, and we do a pretty decent job. Not that they can't be exploited, but again, we've now got some of those processes that the traditional IT communities put in place being applied to our control systems level 4. Our problem right now is the level 3, at the field point of connection and on down to the devices and the controllers themselves, that by definition and design have historically been unencrypted, unauthenticated devices running very simple protocols like Modbus, BACnet, DNP3 that are at this point almost impossible to cybersecure those endpoint devices. So now we need to put in place middleware or other products that can protect these devices. As you can see, we call these passive scanning or intrusion detection with passive monitoring capabilities. These devices typically are only meant to communicate every few seconds. And when we apply IT process like active scanning, it actually crushes those devices and causes them to fail. So again, part of our research community's efforts that you'll hear in a little bit is to help us address these types of problems in the basic architecture and deployment, both of the legacy systems and now of our next generation systems. So as part of our policy and guidance, we've worked with the CIO and put onto place the RMF Knowledge Service Portal, the EINE Installations Environment Control Systems webpage. It's a wealth of information of reference documents, step-by-step procedures to follow the RMF and how to load it into the CIO's what's called the EMAS IT repository tool. And to the extent that I can put anything that's for public domain release, I also put that on the whole building design guide at those links that you see there. So if you have access to the DoD Knowledge Service Portal with a CAT card, you'll find, again, the wealth of information there, and anybody can access the whole building design guide. Here's the new UFC that I mentioned, published and released 19 September for the principal investigators, researchers, architect engineers, community, system integrators. This is a key document that you need to be able to fully understand. It details the RMF processes in great step-by-step fashion, and then this is going to be the document that you're going to be required to follow as part of your contract deliverables. In addition, as I mentioned, we worked with Cybercom then to develop advanced techniques and procedures, which then is how to detect, mitigate, and recover a control system that has been exploited or has malware on it. And so these TTPs, for the first time, require then a deliverable of what's called a jump kit CD or rescue CD. And we are now in the process of incorporating those requirements into draft contract language. So here's an example of a Navy BUMED information assurance design guide that we're currently developing. And you can see that the required submittals now have system security plans, information technology contingency plans, disaster recovery plans, hardware, software lists, and then that jump kit CD that I just mentioned. So again, we're changing our procurement and acquisition processes to incorporate cybersecurity in the initial planning phase through the design, construction, delivery, and then finally decommissioning. So these guides that I'm pointing out here, again, become a central part that all of our investigators and community need to become familiar with. So what's next? As I said, the scorecard, we're going to hopefully have that debuting here in the fall of 2016. There's an additional effort underway now within DoD to do what's called mission assurance and tie missions at each of the installations to the critical systems and control system and critical infrastructure that support them. That project actually kicks off today, and we'll be going through the next 4 years or so. We'll try to do 3 installations a year. Johns Hopkins Applied Laboratory is currently working on cyber threats gaps in the workforce, with those reports coming in here in the fall of 2016 that will help us then develop additional guidance and policy. A great accomplishment was to get cyber ranges to then adopt a control systems competition. That's scheduled for 2017. Again, now we'll begin to see the control systems brought into the cyber ranges across the services and across the joint staff. Another key item on the acquisition procurement, we were successful in getting the DFARs changed in December of 2015. That requires all of our contractor vendors that are supporting DoD to have their business IT systems meet the same NIST RMF processes as the DoD. This is extremely important because as these A&E designers, contractors, system integrators, investigators create your project designs in CAD and BAM and your technical specifications, all that information needs to be protected as controlled unclassified information. And if your business systems are exploited in the same manner that the target HVAC contractor was exploited to get into the target systems, well then you can, an attacker can use a contractor vendor system to potentially access the DoD networks. So again, that process is now started. Compliance date is set for December of 2017. So if you're a contractor vendor, realize that you're going to need to accomplish that here in the next year and a half or so. So finally, in conclusion, again, all control system projects must follow the RMF process. We are designing cyber in from the beginning. The CIO RMF portal and the whole building design guide provides the general guidance and resources, and keep appraised of what is on those 2 sites. The new UFC and TTPs provide that detailed guidance and required deliverables. But again, not all of these requirements will apply to every project. It's going to depend on the type of project and whether or not they need an interim authority to operate on the DoD network. But again, realize that you're still going to follow the RMF processes. And finally, ESTCP office is planning to provide subject matter expert support to the project teams to help them complete their RMF packages, and hopefully that will be in place before the end of 2016. And so with that, here again is the website that you can download the PowerPoint presentations for today, as well as all those documents that I just pointed out, the UFC, the TTP, and the DFARs. So, Rula, with that, I turn it over to you for question and answer.
Great. We have received a number of questions, and I'll start posing them to you. Can you please start by telling us what the typical RMF package deliverables are for an operational technologies RMF package?
Sure. If you go back to the slide, let me go back here a couple slides if I can. So under this required submittals, you can see, for example, a number of documents, but there's really about 7 key documents. The system security plan, the configuration management plan, disaster recovery plan, information technology contingency plan, incident response plan, and plan of action milestones, and finally a security audit plan. So whether you're doing an IT system or OT system in the RMF, those are the kind of the key documents that we're going to be looking for. And once it's pretty challenging to do your first set of documents, but after you've done the first set, then from that point forward you get the templates and then the processes to follow, and it gets easier and easier as each one goes on.
Thank you, Dr. Chipley. A question from Bosch. Can you tell us if new contractors and vendor IT business system requirements also apply to businesses who recently applied for ESTCP funding?
Yes. So if you're new to the ESTCP program, the first thing that I'd recommend is that you download the Cybersecurity Evaluation Tool off the DHS ICS CERT website. Download the documents that we just are going to post down to the SERDP-ESTCP website. And then as you read through those documents and have questions, contact the ESTCP office for specific guidance in areas that you would have questions on.
Thank you. A question from the U.S. Army Corps of Engineers. Are there provisions underway on the government side to fund system ownership activities in the RMF process and to help identify the appropriate system owner for a particular CS project?
The answer is yes. It's a bit more complicated to be able to explain on the phone. But what we did is we worked with the CIO to incorporate into the DFAR and the SNAP IT budget and IT resource tools. And then we've got OMB guidance for 2017 to now identify what cybersecurity technologies, contract support, et cetera, need to be acquired to cybersecure these resources. If you go onto the DoD RMF portal, that specific guidance is there, or if you want to follow up and send an email to Timothy and myself, we can provide that text and then additional details on how that is planning to be worked out.
Thank you. Can you tell us if the SSP is a separate Word document, or is it just a tab in the authorization package?
This is a two-part question. So if you're the contractor, vendor, system integrator, principal researcher working on a project, you're going to use the CSET tool to develop your system security plan, which in essence is the answering of the security control questions. And then that is produced as a Word or a PDF document. And then what we do is we take the output of that tool and copy-paste it currently into the DoD CIO's EMAS program, which then, again, is the same questions, and then the EMAS program itself produces the security assessment report and the system security plan as part of its outputs. So again, from the contractor, vendor, researcher community, we highly encourage you to use the CSET tool, and we've also published and put onto the STPC site an exact replica of the EMAS program in Excel format, and it's called the RMF Core Security Authorization Package. So again, you can use both of those tools outside of the DoD EMAS program to complete your RMF package.
Thank you. Another question from the U.S. Army Corps of Engineers. Will there be new virtual range specific to building control systems or components, or will existing test sites begin testing any major vendor products? And this question is arising because there appears to be so many of them.
Correct. So currently the Navy is building out their test bed center in Port Hueneme. Air Force is doing theirs in San Antonio. Corps of Engineers has established Huntsville as the Cyber Center of Expertise, and then Marine Corps is building out a full capability with Schweitzer Engineering Laboratories equipment at Quantico. The intent here is that there will be test and development environments and range environments that are both virtual and physical replicas of building control systems, utility control systems, environmental control systems. That is one of the primary policy objectives of the next 3 years. So look for many of those cyber range capabilities and testing of vendor products to occur. Our objective is to get type accreditation of our vendor products and then use reciprocity so that if we have a standard configuration, we can roll those RMF out across the DoD at reduced cost rather than $250,000 or more per RMF package per system. That's not sustainable.
Thank you. And one last question before we let you go. Can you discuss which systems or give examples of company systems that will require compliance with SP 800-171?
Sure. So the 171 applies to the company's IT business systems. So this would be where your traditional email, accounting, project management, project design files would reside. And so the 171 is a shorter list of security control questions that a small business, moderate business, large business will be able to, should be able to fairly quickly go through and then put in place basic security principles. And the biggest issue here is that you're going to need to do a monthly or quarterly security audit of your IT business systems. You know, somebody has to go in and verify logs and that configurations are set and that you haven't all of a sudden exfiltrated terabytes of data to a Chinese IP address. So that, again, is a behavioral, cultural change that we're all going to have to implement. But once you've done it first time, it gets easier and easier. So that would be something I'd recommend to all of the folks out there is begin to plan how you're going to do your monthly, quarterly security audit process.
Great. Thank you so much, Dr. Chipley. We really appreciate you joining us today and answering these questions so well. And at this point, we're going to move on to our second speaker today. Mr. Kevin Jordan has over 30 years of military experience in strategic planning, management, and operation of large command and control architectures. He and his wife, Dr. Diane Jordan, founded Resurgo, a network engineering services company, in 2011. Resurgo has developed a rigorous life cycle methodology of cyber defense experimentation for complex, large-scale networks and command and control systems for government and industry. They are currently partnered with government and industry partners in several programs of research, development, and experimentation for the security of SCADA and industrial control systems. Mr. Jordan has a BA in psychology from the University of Pennsylvania and an MA in national security studies from the U.S. Naval War College. And with that, I turn it over to you, Kevin.
Well, thank you, Rula, and it's a pleasure to be here this morning. So I've included a brief problem statement about why we have challenges defending critical infrastructure on bases and installations, and I think Dr. Shipley's brief really laid out in detail why those infrastructures are very difficult to defend. And frankly, they haven't been considered as warranting the attention of cybersecurity experts in the past who have been almost exclusively focused on command and control. One of my concerns is that the approach that many of the operating forces are encouraged to pursue is what I call code of best practice, where you try to keep everything patched and up to date and passwords appropriately changed and so on. My concern there is that strategy for a defense is really not effective. And it's very labor intensive, so you can put a lot of time and effort into it, but the reality is you can never have everything patched. Some of the equipment in these critical control systems can't be patched anyway. And I think there's an assumption that air-gap systems are safe from attack, and of course we know that indeed that is not the case. So remote access is a real problem for our industrial control system architectures. The uniqueness of the systems that prevent patching or where patching is simply inappropriate. Also, the typical patches only protect against known attacks, and now we're faced with the threats from polymorphic versions of attacks that for which there are no signature. And of course, best practices deteriorate over time. So what we need is a new approach, which I think should be a layered defense in depth. And the layers should consist of both hard and soft layers. And I will get into that as I proceed through the briefing. So our solution was to propose in an ESTCP project to demonstrate a defense in-depth approach for protecting an industrial control system for the electric utility grid. However, we're proposing to demonstrate both a fault and intrusion tolerant defense, because we think to be able to deal with both fault and intrusion tolerance is necessary to deal with the most sophisticated threats, or threats which we would define as advanced persistent threats that we typically see from nation-state actors. Critical infrastructure supporting military bases requires a fight-through capability where even under attack, systems somehow continue to function. Now, we think that's possible where systems are designed, architectures are designed to include both fault and intrusion tolerant defenses. And we think the technology is available to do that, although we have to go to some of the newest research technologies available through DARPA. Some of these technologies have not been used before, and others are direct lifts from what we've used on command and control networks. So why defend commercial power? I think that's obvious. Most of our bases are actually supported by commercial utilities, and although with the SPIDERS program we're developing capabilities to provide backup power and alternative energy power on the bases, we really need to look at creating and demonstrating defenses that our commercial utility partners can actually adapt and implement on their systems. So we'll discuss 5 different technologies today, arranged in a layered defense in depth that we think offers at least an approach to how to begin to defend the utility grid. And of course, the defense in depth is much more difficult to attack than systems that are not defended in a coherent way. So I'd like to spend a minute talking about fault tolerance. So fault tolerance is the ability to continue to function despite physical network disruptions. And we've all heard of this fiber-seeking backhoe or Murphy causing things to go wrong. Within the Navy, they talk about the dragging anchor attack, which all too often disrupts fiber cables strewn across harbors and so on. So a fault-tolerant defense ensures that there's appropriate resiliency so that that critical communications can be effectively alt-routed at the speeds necessary to fully maintain SCADA systems that are operating across that fault-tolerant architecture. And then a word on intrusion tolerance. So intrusion tolerance is the ability to continue with the mission despite the presence of even an advanced persistent threat in the network. We have to assume that we indeed will be penetrated at some point. So we need to look at how those penetrations might be detected and stopped. For example, in the attack against the Iranian centrifuges, that architecture was logically isolated, but that did not stop the attack, which jumped the logical barrier. So intrusion tolerance is the ability to function despite the fact that some of the critical components are indeed effectively attacked by an adversary. So we'll discuss a technology from Johns Hopkins that offers an intrusion tolerant SCADA master within a utility grid. So we're assuming in this approach towards fault and intrusion tolerance that the standard backup capabilities are in effect, so that the industrial control system architectures do have path redundancy, that there are backup generators, etc. But even those standard backups are not sufficient to enable the type of fault and intrusion tolerance that we think is necessary to offer a fight-through capability for continued mission prosecution in the event of a cyber attack. So the technology overview, we start with a machine learning sensor. We've been working with the Oak Ridge National Lab employing a machine learning sensor on command and control architectures. And that's one of the options we're considering for this demonstration. The interesting aspect of the machine learning sensing as applied to industrial control system defense is that we know from our work with command and control systems that machine learning sensors can be very effective in detecting polymorphic versions of known attacks. So they can detect known attacks, and they can certainly do that in conjunction with signature-based sensors. But where signature-based sensors don't detect polymorphic versions very effectively, properly trained machine learning sensors offer that capability. The spines overlay communications architecture we will feature is actually developed by Johns Hopkins University, the Graduate School of Computer Science. And I think of the spines as an enclave, actually. It's an enclave architecture which is constituted through establishing an overlay for critical communications between, in this case, the SCADA master and the endpoints controlled by that SCADA master. So what Spines offers us is not only the ability to isolate those critical components of the SCADA system or the ICS system, but it also is very effective in preventing the man-in-the-middle attack, which is one of the threats we have to be able to deal with. Next, we have another technology called Prime, also developed under DARPA funding at Johns Hopkins University Graduate School. So Prime is really a multi-compiler defense, and we're looking to use that to protect those machines in the ICS architecture that are, let's call them full-up computers. And the way Prime works is that it allows us to instantiate multiple replicas of a technology, of the operating system of the SCADA master. And in order to successfully attack that, you have to have an attack that is effective against one of the compiled solutions, but even that would be ineffective because you have to defeat at least half of the number of replicates and physical systems plus one in order to overwhelm the multi-compiler defense. Now, this has not been done before on a SCADA architecture, although it has been demonstrated in the Johns Hopkins University lab. So we're confident that we can show an effective multi-compiler defense. And finally, we're looking at endpoint defense. By that I mean defenses that protect RTUs and RTUs and programmable logic units. So this technology, also developed under DARPA funding, will be provided by a company called Red Balloon Security. And what it does is it puts a security wrapper around these endpoint devices that prevents unauthorized manipulation of the logic in the firmware. Now let's look at what happens when we employ this together. So this operational network view is an attempt to display a NIST-derived architecture that have those features that would enable us to have a layered defense in depth that is both fault and intrusion tolerant. So you can see from the legend up at the upper right, the boxes, I would start with looking at the light blue, the boxes that are protected within the spine's overlay, and then the boxes that have some sort of prime multi-compiler defense. And then finally the dark blue endpoint devices that can be protected by the symbiote security wrapper. And also notice that I've identified the threat vector. So there's the threat coming in through the internet. There's the threat vector 2, which is one possible lodgement for an advanced persistent threat that has come in over the internet and then lies dormant until it's ready to execute. And then finally, the threat vector 3 within the SCADA LAN or control network itself. So we think this defense of fault and intrusion tolerance will deal effectively with all three of those threats. Potential technology transition paths. First of all, NAVFAC is our partner in this ESTCP, is the transition partner and is looking to use these technologies that prove successful within Navy maintained and operated utility grid at various bases, to include Pearl Harbor. And we're looking to the Pacific Northwest National Lab, and there's a typo there, our partner, Hawaiian Electric Company, as potential transition partners through the commercial sector. Acknowledgements. These are essentially the sponsors, to include the ESTCP program office itself, but we're working with the Hickam Energy Office, Mr. Ross Rowley, who led the SPIDERS JCTD. We are using technologies that were developed under the DARPA I-20 MRC and CRASH program. That would include spines and prime, as well as the symbiote technology. Also, the work on machine learning sensors that we've been doing has been in part sponsored by DARPA under a separate R&D program. So we want to bring those capabilities to the mix of layered defense as well. And then finally, NAVFAC N6 is funding one of the technologies employed in the endpoint defense. So with that, Rula, I will turn it back to you for any questions.
Great. Thank you so much. We did receive a number of questions for you, Mr. Jordan. You began your briefing with a statement to the effect that the current practice of Code of Best Practice Defense is ineffective. Can you please elaborate on this statement?
Yes. It's ineffective because I think it's based on an erroneous assumption. And that assumption is that even if everything is effectively patched that can be patched, that you will have a useful defense. The fact of the matter is that the numbers are too great. There are too many machines, and it's too labor intensive, at least on a large network, to ensure that everything that can be patched is properly patched. And even if it is for a brief period of time, it will become unpatched when some new software is loaded and so on. But I will say that where you use an enclave defense, like the spines overlay, machines within that enclave are actually much less vulnerable, even though they may not be properly patched, because breaking into that enclave is going to be very difficult. So that's an example of how layered defense allows some aspects of the defense, like we'll call it the soft power of Code of Best Practice, to actually reinforce the hard barrier of an enclave defense in terms of spines. So my point is that Code of Best Practice by itself is ineffective. However, when combined with a layered defense in depth, it can certainly improve security, especially against insiders within a constituted enclave.
Thank you, Mr. Jordan. In your concept of layered defense in depth, are the layers standalone or are they interactive?
Well, they do have value as a standalone defense. For example, the spines overlay is a powerful protection against intrusion from the outside, but it doesn't do anything to protect from a malicious insider that has legitimate access to the enclave. So layered defense works much better where the layers are interactive. And in the case of our defense in depth, what we propose to do is have the sensing capabilities both inside and outside the enclave report to a SIEM or sensor integration event management system or correlation engine, which is depicted in the diagram, that shows how, say, an alert from Symbiote, which is an endpoint defense, if somebody attempts to manipulate that protected programmable logic controller, it sends an alert to the correlation engine, which then immediately tips us off that there may be an insider threat if we have no indication that a penetration has happened from the outside into the spines enclave. So layered defense in depth where the layers are interactive are much more powerful. I would say orders of magnitude more powerful than standalone defenses.
Thank you. Can you elaborate on the spine solution? Specifically, has it received accreditation through RMF, which is currently active on Navy sites, and is it ready for rollout? And this is a question from the Army Corps of Engineers.
Okay, so the spines architecture, to my knowledge, is, and I'm fairly confident in what I'm about to say, is not employed on any industrial control system architecture, either within or outside the government. However, it is used extensively commercially. It is used to assure delivery of vital video communications for all, and I mean all of the major news media, CNN, Fox News, NPR, etc. And it's also used by the financial industry to assure connectivity and delivery as well as enclave protection for vital financial services that have to be shared among financial components. So it's a very high TRL level. I would say TRL 9 because it's in commercial use, but it hasn't been applied to government use yet. This will be the first time in this ESTCP.
Wonderful, thank you. Can you please elaborate on the distinction between fault and intrusion tolerance?
Yes, the fault tolerance is really something that most cyber network defenders are accustomed to, and they deal with it by backup equipment and redundant paths. The problem is there are very sophisticated attacks that can infiltrate a network and let's say a router control plane attack that infiltrates a network and denies effective routing of selectively of critical communications while allowing other things to route properly. So that type of attack is very difficult to detect unless you have a fault-tolerant defense that actually shares intelligence about the reality of the different available paths within the architecture. And that type of intelligence can actually be used to detect an attempt to manipulate the routing architecture that would be otherwise very difficult to detect. So that's one of the things we want to demonstrate in terms of the fault tolerant, that we can actually deal with a router control plane attack and still route the vital SCADA communications effectively. Now the intrusion tolerance is in some ways more sophisticated. It's looking at protecting full-up computers that provide vital functions within the SCADA architecture. We're assuming that some penetration will happen, but we're setting the conditions that make an adversary's successful disruption of the vital function very difficult. So if you're running 2 physical SCADA masters and they're backed up by 5 replicas, and all of those 7 systems are separately and they're distinctly compiled. So each one of them is different, but they're running precisely the same program, and they're delivering precisely the same result at the same instant. For an adversary to have to come in and figure out, well, he knows that he's got an attack that's effective against a certain brand of the Siemens architecture, like was done in the Stuxnet attack. In an intrusion-tolerant defense, that attack would have only knocked over, say, 1 or perhaps 2 of those physical Siemens machines, but the multi-compiled versions would have frustrated that attack from overtaking the system, and the SCADA architecture would have run normally as if nothing happened. Although noting that the attack occurred would be very valuable, and that information would be relayed to the sensor correlation engine.
Great, thank you, Mr. Jordan. We have a few more unanswered questions, but we'll leave them to the final Q&A. And now I would like to introduce our final speaker, who is Dr. Daniel Quinlan from Lawrence Livermore National Lab. Dan is a research scientist and the leader of the ROSE project in the Center for Advanced Scientific Computing at El&E. His research is in numerous areas that intersect computer science and mathematics. His interests include compiler research and development of tools for custom analysis and transformation of source code and binary software. Dr. Quinlan earned his PhD in computational mathematics from the University of Colorado. And with that, I turn it over to you, Dan.
Thank you very much. Let's see. Okay, I'm off mute. Okay. So let me proceed with the first slide. Let me just set the context of this briefly. We're interested in the analysis of software for security, and in this context, this means software that is loaded onto hardware devices, which is frequently referred to as firmware. So I'll refer to firmware in this talk, and that means software. And specifically, since we don't have the source code, it means binary software, the binary executable. And so where we're doing analysis on the binary executable. The challenges associated with this is that cyber attacks could have significant impact on military operations at DoD bases. The insertion of vulnerabilities is a known vector for how to attack both building automation and electric grid infrastructure. And even if it's not intentional, software development errors can often provide cybersecurity vulnerabilities in firmware. And so these are the challenges that we have. The shortcomings of current approaches is that while vendors may in fact apply secure development practices, they often don't have any control over binary libraries that they use within their software, and so this ends up being a supply chain integrity sort of issue. So I'll refer to supply chain issues within my talk as well. In addition to that, the identification of vulnerabilities and malware in firmware is rarely performed actually at the facility where the firmware will be installed onto new equipment. In addition to that, there's no automated tools that we're aware of for field engineers to test firmware. So it's sort of an open hole in terms of there being no real defense against this at present. The technical objectives associated with our project, which is just beginning, are that we want to mitigate the risks of malware and vulnerabilities in firmware. We want to take a set of existing binary analysis tools for firmware analysis and make them more robust for DoD. We want to test and evaluate these tools and this technology on test beds at P&L and also at a DoD installation. We want to define how it is these tools can be used to be integrated into the maintenance of electric grid substations and building automation systems. And we want to integrate these tools into security assessments for base infrastructure. The last bullet really kind of sums this up. We want to improve security best practices through the use of tools that would actually look at the software directly. There's a technology which we bring to this. Specifically, we have a software analysis technology called ROSE, and our work is to build on top of this ROSE compiler infrastructure with these tools in order to provide this technology. So we have existing tools from the Supply Chain Integration for Integrity project, SciFi, which was a project within DOE, and we have a tool infrastructure called ROSE, which we use to build these sort of tools. Now, ROSE itself, I have a few slides which mention that, but ROSE itself provides a base level of technology for all of our tools and for many other tools that are built elsewhere as well. So, for example, it provides the ability to disassemble the binary executable, a variety of prepackaged forms of analysis, including the ability to write custom analysis as necessary to implement specific tools. It also includes mechanisms for the presentation of results, etc. Now, ROSE itself is somewhat unique in the sense that it's an open source infrastructure having been developed for over 15 years at Livermore National Laboratory. It provides both mixed static and dynamic analysis. It provides a representation of the binary that is critical for malware analysis, and It provides the underlying infrastructure for us to build tools. The methodology that we're going to apply within our project is to take the tools developed under Sci-Fi and improve them and expand upon them for purposes of evaluation at a DoD base. Now, the ROSE infrastructure is addressing both source code and binaries, but for this project, I'm showing here how it is we're using a subset of ROSE in order to focus on the binary analysis work necessary for this project and for these specific tools. So we're using the front end, we're using the binary executable processing, the representation of the AST and the ROSE IR, and the static and dynamic analysis that we have, as well as analysis presentation tools. So this project is addressing specific tools, and so I've listed the tools as binary analysis tools BAT 1 through 5, and the figure actually represents an overview of the specific binary analysis infrastructure within ROSE, and we can handle inputs from a variety of different sources, including firmware, firmware load files, and also binary executables, and many others. There's a support for a number of different instruction set architectures, x86, PowerPC, ARM, etc., Motorola, 68K. The point is that we can support a variety of different types of firmware in our analysis. And then there's different types of analysis that we can bring to bear. And then from all that, we build these tools. So we have BAT1, which is an anti-disassembly detection tool, all the way through BAT5, which is a path feasibility analysis tools. And I'll show you an example of these two just a little bit later. The history of applying ROSE is that we've applied this to both mission applications within the development of tools for DoD and DHS in conjunction with the Software Engineering Institute at Carnegie Mellon. We've also been using this within DOE for specific software analysis tools as part of HPC, high performance computing, and within the nuclear stockpile stewardship program, specialized tools for analysis and optimization of codes for large-scale computers. We've done a number of different technology demonstrations, finding specific vulnerabilities in SendMail, which is used worldwide for email, and that was a binary analysis. The analysis of hundreds of different Linux utilities, again, that was a binary analysis. And then as a source code analysis of ZIM, which is used in the Amazon cloud infrastructure for specific vulnerabilities. We're also a research group, and so we've competed in a number of different settings, and in 2009 won an R&D 100 award. And more recently, over the last several years, we've been involved in software verification, where we've won awards from 2012 through just this last year, specific to analysis of software for verification purposes. There are specific technologies that we're using. First one is specific Sci-Fi tools. These tools include the recognition of anti-disassembly techniques, which is only really ever associated with malware, so that's a good correlation there. Backdoor analysis, identification of specific properties on firmware, and most of these tools that we develop are released open source in ROSE, but a number of these are not, and the tools specific to ESTCP will not be released in ROSE. But we do release a lot of different sorts of tools in ROSE, and ROSE is open source. The additional development that will be done under this project will be to improve the robustness of the prototype sci-fi tools, providing tool interfaces for different sorts of users, addressing specifically the target of a user who is in fact a field engineer, and also testing and the evaluation on test beds. PNNL, Pacific Northwest National Laboratory, has a test bed for building automation systems that they're building, and also substation electric grid infrastructure. We're gathering firmware from different sorts of devices and expanding the capabilities of the tools that we have as we go, and the focus is on communicating results to users and also vendors to understand detected properties. Some of the tools that we're developing are in fact have as an audience the actual vendor. And some of the tools have as an audience the field engineer. I wanted to give you examples of two tools specifically. This is BAT1. It's a detection of anti-disassembly technology in firmware. And this is done on the binary. In this particular case, you can see on the right the figure representing a piece of firmware that has been, in this particular case, it's a piece of malware, and the grayed out boxes represent regions that have been added to the software in order to make it very difficult to figure out what the software does. So this is a tool that addresses how it is firmware engineers, reverse engineers could more easily support analysis of the code, but the detection of this sort of anti-disassembly techniques, and there's about 16 of them, is a high correlation to malware. In the grayed out boxes, specifically what's important to note about them is that they are equivalent to no-op operations. They have no semantic influence on the state of the machine. They are more sophisticated than no-ops, or they'd be trivially recognized and eliminated, but they do things like add one, subtract one. They do operations which are meant to change the state and then revert the state back, and in doing so make it very difficult to do both analysis and also provide a mechanism for polymorphism and malware. But the existence of this sort of technology is always suspicious and related to something that you want to know about. And so you shouldn't really see this in firmware, for example. The second example is specific to the async safe handler vulnerability. This was a vulnerability in SendMail, and it was identified in 2001, and we wrote a detector for this. This specific type of vulnerability is one that is no compiler will check for it. It has to do with the use of handler functions that include system calls that are not on a whitelist of async safe handler calls. And in this particular example, we're showing you the call graph of the binary. The call graph is dense. If you look at the close-up, you can see orange boxes. Those boxes represent functions, and the lines represent calls from one function to another function. And the specific vulnerability is this red line that exists between a collection of functions that are being called, one chain in the control flow path, that is where this violation occurs. And no existing tools detect this, and so this was one of the first tools that detects this on binaries. We've previously written source code analysis tools that detect this on software as well. So the analysis of data will be an important determination for our success in this work. We want to be able to collect the data from these tools and then integrate them into a best practice guide that will show how to improve firmware update security with these tools. And another important criteria for our success is that we fully automate this process. So we've been for years focused on tools that fully automate the process of doing these sorts of analysis, and that's a focus within this work as well. We have a technology transfer plan. First, the project team expects to work closely with the selected site to better understand what the devices are that are present at the site, and back out from that what sort of firmware is present, and get copies of those firmware so that we can support our demonstration. But also Boeing is a part of the project, and in that context they'll be evaluating the commercial opportunities to either sell the tools or sell a service using the tools, and we'll decide which is the best approach to that. Both Livermore, Pacific Northwest Laboratories, and Boeing have significant experience in commercialization of advanced technologies, so we've all been doing this for a long time. We expect the first potential users to be base maintenance personnel, infrastructure security assessment teams, and critical infrastructure vendors. There are a number of related efforts. I referred earlier to the SciFi project. It's the Supply Chain Integration for Integrity. That is a DOE Office of Electricity project that just recently ended a few months ago. There's also work related to this in the DOE NNSA Stockpile Stewardship Program, where they've made significant investments in ROSE for code verification and performance analysis and optimization, and also within the OSCAR program within DOE, that's ASCR program, and they've made significant investments in ROSE specific to the exascale computer research program within DOE. IARPA has also contributed to ROSE and development of specialized sorts of technologies for projects there. And we've also had internal funding from DOE Livermore to support general binary analysis capabilities over the years. So we're pulling from all that in the construction of this project. There are expected DOE benefits to this. We want to automate the analysis of firmware so that you don't have to have any specific talents in binary analysis in order to use these sort of tools. We want to lower the cost of analyzing firmware and provide a quicker feedback. We want to enable technicians who are untrained in cybersecurity to identify suspicious software, which may in fact then go for further analysis. We want to integrate into existing security assessments, and that's very much a part of the project to define how that would work. And we want to improve supply chain integrity for mission critical energy systems and also building automation systems. So a number of people have been are a part of the project, and so this is just a slide listing the co-PIs, the program manager, and some of the people and their specific expertise. And this is the last slide, so I'll end here. Thank you.
Great,
Rula.
thank you, Dr. Quinlan. We've received a number of questions for you. So the first one is as follows. If I download and install ROSE, will I be able to run any of these five binary analyses tools?
I want to listen on the speaker. He's asking.
Some of the these specific tools in their context for SciFi, some of them are available, some of them are not. So for example, the backdoor analysis work is not. But some of those tools are available. However, the ESTCP tools will not be released in ROSE, so the final versions of those tools will have to be made available separately, and it's not clear what mechanism, and we will work with ESTCP to decide what that will be.
Thank you. how hard is it to add another instruction set architecture into ROSE?
In general, it takes several months to add a new instruction set architecture into ROSE. It requires some very specialized talent. It's something that we consider to be outside of the scope of the ESTCP project, but it's something that we do periodically in order to address specific requirements for tools.
Thank you. If the ROSE analysis tools don't identify any vulnerabilities, does that mean that one would have safe firmware?
No. If you don't, the absence of vulnerabilities does not imply any concept of verification of correctness or otherwise. The two concepts are very separate. We work on both verification and we work also on vulnerability analysis. We understand the difference between the two, but certainly because you haven't recognized some specific vulnerabilities given a tool does not mean that other vulnerabilities are not present.
Great, thank you. Can't we trust the vendors that are supplying infrastructure equipment, for example, signing firmware?
The signing of firmware says something about the process of transfer from the vendor to whoever wants to upload the software to a particular device. But it doesn't say anything about the supply chain integrity, and in almost all cases, vendors use software in the form of binaries where they don't have access to the source code, and they use the binaries, and all that gets wrapped up into the firmware that they deliver. So they only have so much control over their own software for that reason.
Thank you. And then I have some general questions that I'd like both of you and Mr. Jordan to sort of weigh in on. Starting with the first one, and we'll go with you, Dan, first. Is it more effective, both cost-effective and otherwise, to harden existing or new systems, or is it better to focus on dealing with vulnerabilities as they arise? Dan?
So I actually think it's better to harden existing systems than deal with vulnerabilities as they arise. There are a number of technologies which one could move to in the development of software, which would provide higher levels of software assurance, and or all the way up through verification, the ability to make sure that there are problems that are not present, and that I think in the future, that'll be the only successful approach.
Kevin, would you like to weigh in?
Yeah. So I think that there's a question of efficiency. It's always more difficult to retrofit a security defense than design it in from the beginning. And of course, we have what we have, so we have to look at retrofitting existing systems now, but in the future we really should be looking at how well we can design defenses that not only offer a means of preventing or disrupting attack, but also defenses that report that some sort of an attempt at disruption has occurred. So it increases the overall situational awareness of the defenders.
Great, thank you. Another question where I would appreciate both your opinions on. Dan, do you feel that the evolution of an Internet of Things offers sufficient advances in productivity to outweigh the security risks of interconnecting everything?
Oh, that's an interesting question. I think it's actually a bad idea to connect everything. I think that until you have systems that are themselves far more secure and verifiable, that it's going to be a problem to connect them all together. And so I guess to a certain extent I would pour some cold water on the concept of Internet of Everything, even though it's very attractive.
Kevin, would you like to weigh in?
Yes, I agree that it's a Hobson's choice, but I think that it's inevitable. I think greater interconnectivity is not something that we can prevent, but it is something that we can be prepared to deal with. And in my briefing, I talked about the value of an enclave strategy. And one of the values is indeed that when you set up an enclave, you essentially disconnect interconnectedness that you don't want, and then you allow connectedness through the enclave through some sort of exception. In other words, you determine that you're going to allow a connection, and you assess the risk of that connection being accessible to information inside the enclave very closely. So if we say we don't use an enclave strategy, then there is a nightmare of interconnecting everything, because it just allows for extensive lateral movement of threat actors through our architectures, and essentially that's what they have today. So we have to come up with defenses that can be implemented to discourage that lateral movement. And so using an enclave strategy is one example of a sort of a retrofit where there's a vulnerability in the existing architecture where we can go in and do something that reduces that vulnerability while we await better solutions to be available.
Great. Thank you both for a very interesting and educational webinar. At this point, I would like to remind our audience that our next webinar is on Thursday, October 22nd, and it will feature 2 resource conservation and climate change program area presentations focusing on DoD decision-making and climate change. This webinar will feature 2 presenters, Dr. Richard Moss from Pacific Northwest National Laboratory and Dr. Casey Brown from the University of Massachusetts at Amherst. Registration is open for this webinar, so please visit the SERDP and ESTCP webinar webpage to register for this and other future webinars. Before we conclude, I would like to remind you that both the audio and a copy of the presentation of today's session will be archived on our webinar webpage in case you would like to refer to them in the future. We would appreciate it if you can please take a moment to complete the survey that will pop up on your screen at this time. This concludes today's webcast. Thank you so much for your attention.